Hey guys, what's up? Welcome back to Classroom. It's Mr. Low, and today we are going to finish up the three-part series of this chapter. Right, so this is the third part of the lecture series, and we are going to discuss on polygons. Right, so in case you have forgotten, let's go back and recap on the differences. The relationship between the different figures. Right, two-dimensional figures. We have triangles that we are all very familiar with. Right, three-sided shapes, and then we have in the last second part of the video, quadrilaterals, n equals to 4, right? So these are four-sided figures, okay? And in this case, now today, we are going to discuss on general polygons n-sided shapes for n greater or equals to 3, right? So polygons can be triangles, can be quadrilaterals, can be five-sided, six-sided figures, so on and so forth, right? So it's getting more and more complicated compared to our triangles and quadrilaterals. Alright, so let's look at the lesson objective for this video. We are going to identify different types of polygons, right? Okay, state the properties of polygons, specifically the angle properties. Alright, we're not interested in calculating the area and perimeter. Right, we're gonna solve the problems involving these angle properties. Alright, let's get into it. First of all, definition, right? So please commit this to memory because this is the definition of what a polygon is. So a polygon is a closed figure. Closed means it closes up itself, right? So for instance, what is not a closed figure is something like this. This is not closed because, well, we have this this opening, so-called, right? So in order to be closed, it has to close back on itself. Okay, not exactly like something like this, right? So this is a closed figure and not an open figure, right? So a polygon is a closed figure formed by three or more lines, as we have discussed this, right? So for a polygon, the number of sides can be 3 or more. All right. Okay. So such as triangles, rectangles, right? These are the things that we have seen before. All right. But at this point in time, I'd like to bring out a common misconception that many people may have, which is the difference between what we call a regular and non-regular polygon. So we have a regular polygon and versus non-regular. Okay, non-regular polygon. Okay, what are the differences between these two, right? Okay, essentially, when you think of for example, let's think about a pentagon. Pentagon is a five-sided shape, right? N equals to 5. What you typically think of is something like this. Okay, so this is a poorly drawn regular pentagon. By regular, we mean that every side is the same. So this is what it means by a regular polygon. By definition, all sides are equal in length. Okay, all sides are equal in length. Pardon the handwriting again. Okay, so for instance, a square is a regular polygon, right? So a square has all four sides the same, but a rectangle is not, as you can imagine, right? Okay, so on the other hand, you have the opposite of regular polygon, non-regular polygons. So you know kind of what it means. So for example, like this, right? So this clearly all the sides are not all the sides are equal, I should say. Not all the sides are equal. So this is a non-regular polygon. Okay, so not all the sides are equal. Right, of course, you might have some of the sides that are equal in terms of length, but not all. Alright, so with this, let's move on. So we're gonna learn a few names that concerns a polygon, okay, be it regular or non-regular. Alright, first of all, a polygon is made of sides, right? So in this case, we have 1, 2, 3, 4, 5, 6 sides, right? So this is a hexagon. Later we'll see some names there. Okay, but this is not a regular hexagon because you can see very clearly this length and this length, they're not the same. Yeah. Okay, so what else? We have an interior angle here labeled. Okay, of course there are many interior angles in this shape. 1, 2, 3, 4, 5, 6. Right, 6 interior angles, which coincidentally happens to be equal to the number of sides, right? So here we have 6 interior angles. Okay, and in this case, the number of sides is exactly equals to 6. So you can spot a pattern there, right? Okay, we also have this thing called vertex. Vertex essentially is one of the corners, okay, of this shape here, vertex. So how many vertices are there? Okay, 1, 2, 3, 4, 5, 6. Yeah, so same as the number of angles and same number of sides. There are 6 vertices, right? The plural of vertex is vertices. And then remember this thing, exterior angle over here, right? We have calculated. Recall in the first part of the video series, we know how to calculate the exterior angle of a triangle, right? So recall, the exterior angle of a triangle is the sum of the two opposite interiors. So in this case, A equals to B plus C. Yeah. Okay, but this is not true for any other polygons. But we have learned from the triangle how do we obtain a exterior angle, right? So the whole idea is this: you just need to extend one of these sides of the regular shape, and then you can mark out a exterior angle, something like this or this, right? Okay, so let's move on from here. We now move into discuss the angle properties of polygon. Okay, so first of all, let's look at number one. Number one, the sum of the interior angles. That means if you add up all the interior angles in a polygon, right? For n-sided polygon. Okay, we are not looking at a specific number. For example, for n-sided polygon, the sum of interior angles given by n minus 2 times 180 degrees. Again, please be careful. You would need the brackets here. Please take note. Okay, so what does it mean? Let's say, for example, we have n equals to 4, right? Okay, let's say we have a rectangle. Okay, now we all know that for the rectangle, we have all 90 degrees right angles for interior angles, yeah? Okay, so what is the sum of the interior angles in this rectangle? Well, the sum of interior angles is 90 degrees times 4, right? 360 degrees, yeah? This is what we get. This is what we know. Let's apply this formula here, right? So for n equals to 4, so this over here, n minus 2 times 180 is, for the case of rectangle, 4 minus 2 times 180, and you get 2 times 180, which is the same 360 degrees. So this is just an example of how you can use. So n is the number of sides for that particular polygon. Okay, next, number 2, the sum of exterior angles in this in an n-sided polygon is 360 degrees. Okay, so that means what it means is that, let's look at this diagram here. Okay, for this particular polygon here, right, if I'm going to add up all the exterior angles, they will add up to 360. Just like this as well. Okay, I'm going to add up all the 4 exterior angles, they will all add up to 360. It doesn't matter what is the how many sides there are. Okay, now at this point in time, I would like to tell you that there is a way to derive this formula here, n minus 2 times 180. What do I mean by derive? The question is, how do you get this formula? Okay, there's a way to come up with this formula. Okay, there is a video on it, very simple, but not very detailed explanation. Okay, it's another video by someone else. Okay, I will link to the video in the description below. You don't need to know how this formula comes about, but I would encourage you to take a look. It is good to know always. All right. Now, if you're going to watch the video, my challenge to you is, once you understood how this come about, I want to challenge you to arrive at this result. So from 1, if I know 1, how can I show that number 2 is true? Okay, so if you have the time and you feel like doing it, please do so, and you can discuss with your teacher when school reopens. But at this point, I need to highlight to you that for these two formulas, please remember very carefully, it need not be a regular polygon. That means it applies for any polygon, can be regular, can be non-regular. If you look at this two examples here, clearly they are not regular polygons, so this still applies. Okay, however, in the next box here, the next two formulas, it only applies for regular polygons. So please take note here, only for regular polygons. You do not use it for non-regular. Okay, so what does this box say? Okay, in an n-sided regular polygon, where all sides are equal in length, well, this is what regular polygon means, right? All sides are equal. Okay, the interior angles are equal. Because all the sides are equal, therefore, all the interior angles are equal. Okay, so remember that in the previous part, the sum of the interior angle is given by n minus 2 times 180. So if there are n number of interior angles and they all add up to this, what is each interior angle? Well, very simply, you just take that thing, divide by n, right? Because they're all equal. Okay, so this is how you remember. Do not try to memorize this. What I would do is, I would only try to memorize these two results. And then for a regular polygon, I know that I can simply divide, the sum by the number of sides, which is the number of interior angles, to get each interior angle. Likewise, from point number 2 just now, the sum of exterior angles of any polygon is 360 degrees. So since, right, there are n number of exterior angles for any polygon, n-sided polygon, sorry, you can simply divide by n to get each exterior angle. Each, we're not talking about one only, right? So in this case also, each interior angle, each exterior angle. Roger? So again, this is only for regular polygons. Please do not mix it up. But for the previous two results is for any polygons in general, regular or non-regular. Okay, so let's move on. We have some examples here of regular polygons. We are only talking about regular ones here. Okay, we can name them, right? So for n equals to 3, we know it's a triangle, but specifically because all sides are equal, we have a equilateral. Yeah. Okay, for n equals to 4, next we have a square, but not a rectangle. Okay, now from n equals to 5 onwards, you start to realize that we specifically name regular to specify, right? Because for example, n equals to 5, we have a regular pentagon, right? Because if you don't tell me it's regular, I might have something like this, right? 1 2 3 4 5. This is a pentagon because it has 5 sides, right? 1 2 3 4 5. But you realize that not all the sides are equal. So this is a non-regular pentagon. We just call it a pentagon in general, right? So for 6-sided hexagon, 7-sided heptagon, 8-sided octagon. Alright, if you can remember this oct should remind you of octopus, 8-legged, right? Okay, 9 is nonagon and 10 is decagon. Yeah, right. It's a mouthful. Alright, now quite interestingly, see, as the number of sides increase, what does the shape start to resemble? See, from n equals to 3 to n equals to 4, so on and so forth, right? As the number of sides increase, what does the shape start to look like? If you tell me it looks like a circle, then you're absolutely right? So a circle can be said to have infinite number of sides, right? Infinite number of sides. Now do not take this down, of course we're not going to test you this, but you can see, right, as n start to increase, the shape starts to approach like a circle. But a circle is not a polygon. Okay, we do not consider circle as a polygon. Okay, moving on. Okay, so practice time. Practice number 1. Let's take a look at the question. Okay, the diagram shows 3 sides of a regular polygon, AB, BC, and CD. Okay, this does not mean that the polygon only has 3 sides. Why? Because 1, 2, 3. If I only have 3 sides here in this diagram, this shape does not close. Remember, the shape must close back on itself, right? Okay, so this is still an open shape, so this is not a polygon. So for this regular polygon, please highlight the word regular. We have no idea how many sides it has. So let's just call it n-sided, okay? As usual, all right? But we do know that it's a regular polygon. Okay, the question tells you, given the CBD, this angle here is 15 degrees, and the polygon has n sides, okay, as we've discussed just now. Okay, calculate the angle of each exterior angle in the polygon. So we are interested in exterior angle. Please don't go and calculate interior angle. Okay, so this is part A, and part B, oh sorry, I've already noted down here. Part A is here, find each exterior angle, and part B, hence, okay, so please be careful here. Hence means you must use the result from part A. Find n, right, the number of sides of the polygon. So how are we going to do this? So first of all, let's look at the diagram that we are given. Okay, we are only given one angle here, 15 degrees. Do we have other information? Yes, we do. This is a regular polygon. And what does that mean? This means that all these sides are equal. Do you agree? Now, once we have this, can you see that we have a isosceles triangle now? So do we have another angle? Yes, this is also 15 because of isosceles triangle. So from here, we are able to calculate this, which is 150 degrees. Right, angles BCD is 150 degrees, but what is so special about BCD? This angle BCD here turns out to be one interior angle. Alright, it's one of the interior angles, so with this in mind, 150 degrees, are we able to then calculate the exterior angle? Actually, we can already. So this is how it goes. Alright, so we have a isosceles triangle. We identify that angle CBD is 15 degrees, and then we can calculate BCD to be 150 degrees using the isosceles triangle. And then the exterior angle is nothing but 180 degrees minus the interior angle. Why is that so? I'm going to pause here for a while. Okay, let's go back to the diagram here. Let's zoom in here, right? Let's look at x4. We have x4 as one of the exterior angle, right? Exterior angle. Which one is the interior angle that is paired to this x4? Well, it's actually just this, right? This is the interior angle. Can you see that they both lie in one straight line? So can I say that these two guys, the exterior angle and its counterpart interior angle, add up to 180 degrees? Right? So very simply, very quickly, once you have found the 150 degrees here, this interior angle, we can then find one exterior angle by taking 180 minus the interior angle, and we are done for part A. So answer is 30 degrees. Okay, in part B, we are supposed to find, using the exterior angle that we've calculated here, 30 degrees, to find the number of sides. So we'll recall that for a regular polygon, the exterior angles add up to 360. So each exterior angle is 360 divided by n number of exterior angles. My bad. Okay, sum of exterior angles in a polygon is 360 degrees. So we do know that, we don't know what is n, right? That's what we are supposed to find, but we do know that each exterior angle is 30 degrees. So I can have this. So by doing that, you can straight away find n to be 12. Alright, moving on. Okay, here the question says a polygon has n sides, but at this point in time, please be careful. This need not be regular. So let's just assume that it is non-regular, right? Okay, two of its exterior angles are 21 degrees and 54. So clearly, it is not a regular polygon, because if it's a regular polygon, all the exterior angles must be the same, right? And the remaining angles, the remaining exterior angles are 15 each. How many exterior angles are 15 degrees? N minus 2, right? Because there are n number of exterior angles and you already have this 2. So the remaining is n minus 2. So hence, using this, find the value of n. Okay, so the way to do this is, okay, we have we have information about the exterior angles. So we use our knowledge that the sum is 360 degrees. But we cannot simply divide it by n number of sides because this is a non-regular polygon. Okay, so we're going to just add up all the exterior angles. We have the 2 that we already know, and the rest are 15 degrees, and there are n minus 2 number of 15 degrees. So we're going to add them up. Okay, from here onwards, what I'm doing is the so-called rainbow method, distributive method, and this is how I get this 2. Okay, so this 2 gives me this 2, while 21 plus 54 gives me 75. Okay, the rest from here is just very basic algebra, and you can solve for n. And you realize that this polygon here, non-regular polygon, has 21 sides. Okay, moving on. In part B, they ask for the sum of interior angles of this polygon. Right? So recall, okay, the sum of interior angles for any polygon is given by this formula, n minus 2 times 180. Right, in part A, we already know for this case, this is a 21-sided polygon. So we simply substitute n equals to 21, and we have the answer. So for this particular 21-sided polygon, all its interior angles add up to 3,420 degrees, which is pretty huge. Pretty huge. Alright, next. Okay, so we have this polygon here. Oh, it's a pentagon, right? Because it has 5 sides. 1, 2, 3, 4, 5. Okay, so it has 5 sides. This is a pentagon. But again, no saying that this is a regular pentagon. As you can see, the sides are kind of different, right? So be careful of which formulas you're going to use. Okay, what is the sum of the angles? Sorry, the interior angles of the pentagon. What is the sum? Well, of course, most of you, when you look at this question, you are very tempted to just add up all this, all these angles, and then give me the answer as the sum of interior angles. But that's not what the question is asking for. Okay, you're supposed to use the formula to tell me that the actual number itself. Because later, how do I know that? Because later, we are going to find the value of x. So if in part A, you are going to just give me the answer in terms of x, right? Because if I'm gonna add all this up, I have x terms over here, then you will not be able to give me the answer for part B, right? So the sum of interior angles for any polygon is n minus 2 times 180. In this case, we know that because this is a pentagon, n equals to 5. So you simply substitute n equals to 5 inside, and we have 540 degrees as the sum of interior angles for this particular polygon. Okay, hence find the value of x. This is when we need to add up all the angles in the shape itself from the diagram. You add up everything and you equate it to 540 degrees. That is from the previous part, right? We got it over here. Okay, so the rest is just basic algebra. You can do it on your own. And you have x equals to 36 degrees. Alright, so that's it for this part of the notes. We have covered the whole chapter. Congratulations. Please remember to complete the homework from the textbook and submit to your teacher when school reopens. Alright, so let's do a quick recap for this whole topic. Right, in this whole topic, we are dealing with angle properties of polygons in general. Right, so we have done triangles. Okay, for triangles, we have learned for angle properties, right, we have learned two things. One is the sum of angles in a triangle is 180. We learned about this thing called exterior angle and how it relates to the angles inside the interior angles. So this is when we are exposed to the difference between exterior and interior angles. So that is for triangle, nothing very fancy. Then we move on to four-sided figures, which is quadrilaterals. Okay, these are the things that you need to memorize, the different properties of different quadrilaterals. We discussed that, for rectangle is a special case of a parallelogram, okay, and we learned all the angle properties. We also discussed that a square is a special case of a rhombus, and there are certain angle properties in it that you need to know. Last but not least, the one of its kind, kite. Okay, and then lastly, in this last part, in this video, we learned about polygons for different five or more sides, right? Because quadrilateral is 4, triangle is 3. Okay, so for this, we learned some terms, and we learned 2 formulas, actually 4 formulas here. Okay, so the sum of interior angles for any n-sided polygon need not be regular. Okay, it's given by n-2 times 180. The sum of exterior angles for any polygon need not be regular is 360 degrees. For regular polygons, you want to get each interior angle or each exterior angle, you simply take the relevant formula, divide by n, simply because all the interior angles are equal for a regular polygon. All the exterior angles are equal for a regular polygon. Okay, then we have used this to do some algebra to find out the number of sides. Usually it's to ask you to find the number of sides for a n-sided polygon. Usually non-regular, because for regular is very, very simple. Alright, so that's it for this topic, chapter 11. Okay, I hope you have fun learning this. I certainly had fun recording this video. I'll catch you on the next chapter. Take care.